Okay, hello and welcome everyone. It's great to be here for one of the first parallel sessions. I hope you attended the welcome out in the lobby and the keynote speech. This session is on using LCA for looking at transformation towards future mobility, and it's being chaired by Aleksandar Forell from Makersite in Germany, and by me, Anna Björklund, from the Royal Institute of Technology in Sweden. And we have 4 speakers that will be presented soon. But before we do, we just want to inform you that the audience, if you have questions, you're not able to speak up, but you can post your questions in the question and answer session to the upper right of the screen. There should be such a field where you can write questions. And Aleksandar and I will do our best to moderate your questions and help speakers by reading them out loud to them. Okay, and once that's been said, a little bit of background to this session, what made us pitch this session to the conference organizer. Is the fact that transportation is one of the largest and fastest growing contributors to greenhouse gas emissions in society. And there is really an urgent need for transformative change in the mobility sector to reach urgent climate targets. And there is really high expectations on the potential of new technology and new fuels and the ongoing electrification to help us reach those targets. But along with that, there is also a need for significant change in policy and business models and consumer behavior. And there is also large uncertainty about future pathways and emerging technology performance that complicates the assessment of alternatives and strategic decisions. So this session will address these dimensions with a prospective life cycle perspective and looking at both the technology level in industry and at the society level. And as we're mentioning this, I also want to highlight or market another session coming up this afternoon, looking at decarbonized mobility along the value chain. So with the even more technology oriented perspective, so if you're interested in these questions.
So, yes, as Anna already announced, we have 4 interesting speeches today. The first one will be held by, actually, I think Anna's colleague or PhD student, Celeste Lai. She will talk about transformation of aviation energy transformation in Sweden, and the key topic is the environment, or is a combination of environmental assessment and socioeconomic methodologies and the pathways there through. Maybe a few words about Celeste. So she is a doctoral student for sustainable development. She has graduated in environmental science and engineering at the KTH Royal Institute of Technology in Stockholm. And yeah, well, wait a second, I lost my notes, sorry. And yeah, she's working in this multidisciplinary project that she will present today. Sorry, that was a bit of a humbly start. I'm going to be better on the next one. The second presentation is from Anna Salles. She works since 2019 as an LCA expert for the Fraunhofer Institute of Chemical Technology in Germany. She is an expert in recycling efficiency, or she works at the Recycling and Resource Efficiency Management Group at the Environmental Engineering Department, and she has been involved with environmental impact assessment and the application of circular economy and eco-design concepts in different projects, especially in the aviation industry. And in her presentation, she will talk about the Clean Sky program, a private-public partnership between the European Commission and the aeronautic industry. Third is a presentation by my dear colleague Aleksandar Lozanovski, who is basically sharing most of his vita with me. He has basically started and holds a diploma in mechanical engineering, then joined life cycle assessment. He's currently working as a senior researcher in the Department of Life Cycle Engineering at the University of Stuttgart. Is specialized in automotive industry and mobility, dealing with electric vehicles, hybrids, internal combustion engines, carbon dioxide-based synthetic fuels, hydrogen and other biofuels. Yeah, he's also working in other projects in the field of CO2-based products in the chemistry and process engineering, as well as energy systems. And his presentation today is about future mobility in the year 2040. And last but not least, it will be a presentation about me, about integrating design for environment into to achieve carbon neutral mobility. So my name is Aleksandar as well. As said, I share most of my vita with the previous Alex. So I'm also a mechanical engineer. I've been working with LCA for the past 15 years and mostly in and for the automotive industry and with all topics around that. So we have basically also the same touch points. I worked with batteries, fuels, all sorts of materials that go into electric vehicles. So the scope of our expertise is kind of the same. And yeah, I'm looking at the design for environment part. Good. The final slide is Anna doing again, I think.
So now we'll hand over to Celeste to present her work, and we'll have two presentations in a row, and then make room for just a short 5-minute leg stretcher, and then be back for two more presentations. So please, Celeste.
Yes, thank you. Let me share my screen with you. All right. Yeah, good morning, everybody. My topic today is about aviation energy transformation in Sweden. So aviation is a socio-technical system, also an industry that's hard to decarbonize. It's currently relying 100% on fossil fuel. In Sweden, the national goal of net zero emission at 2045 is driving the industry away from using fossil fuel. At the same time, the goal is stimulating the emergence of emission abatement technology. With the introduction of new technology comes systematic changes and societal transformations. And these changes are studied by scholars in the field of transition research. But the scholars, at the same time, often implicitly assume sustainability of technology, overlooking questions like sustainability of transition process or sustainability of any technology when they are in the larger scale, also potential burden shifting phenomenon. So LCA as a method could supplement the social technical transition perspective by addressing these questions. And in return, social technical transition perspective can enrich LCA by introducing different interactions between technology and society. So our research is to assess the potential environmental impact of the future Swedish aviation energy system in comparison with the traditional fossil fuel counterparts. So as an LCA case, preliminarily, we are setting out to assess the environmental impact per energy unit of a return flight over the life stages from well to wake, focusing on Sweden in the year 2045. So since the case is setting into the future, so we will be using prospective LCA. What differentiates our LCA with the conventional LCA lies in step 2 inventory, where we introduce the social technical scenario technique to help us to develop the future scenario. This technique emphasizes on the interactions between the current aviation regimes, innovations, and external pressures, and that study the evolvement of these interactions over time until a new setting is formed. We also introduce cross-consistency assessment methods to help to eliminate any incompatible relationships found in the scenario. So once we perform these steps, we will revise our LCA scope before setting out to collect data. To put all this into a context, let's look at the preliminary scenario we've developed stretching from the time period now to the year 2045, where Swedish aviation is supposed to be fossil-free. At the moment, the amount of sustainable aviation fuel or SAF used in Sweden is minimal. However, there are a lot of ongoing R&D projects focusing on investigating different feedstocks and production pathway to produce SAF locally. But the limitation of SAF in terms of feedstock availability is also stimulating the development of alternative technologies such as battery-driven or hydrogen aircraft. From this year, 2021 onwards, we'll see increasing use of SAF in Sweden, mainly due to the government is mandating the blend of SAF into jet fuel. We also see more national budget being allocated to R&D project to encourage biofuel, electrofuel production locally, and electric aviations. Customers or consumers are becoming more knowledgeable and conscious, and there will be a higher demand of sustainable products, and that's also for our aviation industry. And actors within aviation industry are working more closely together, forming coalitions to accelerate the energy transition in the industry. The same actors, including airlines, airports, OEM, etc., they are more willing to adapt to and invest into novel technologies. Also, we see forest-based feedstock competition across different industries in Sweden at this period of time becomes noticeable. So around 2025 to 2026, we will expect the first battery-driven aircraft entering into service in Sweden. Within this time frame, we expect consumers to be more willing to pay for SAF to cover for their fuel. And there will be large-scale optimized SAF production facility establishing in Sweden, featuring the use of diverse feedstock to be produced in the common facility for the fuel. However, the lack of bioenergy carbon capture utilization governance would delimit the potential of electrofuel development here. So making importing SAF necessary to meet the 30% volume blend mandate at 2030. Moving on, around 2035, we expect to see the first hydrogen-fueled aircraft ready for flight testing. At the same time, the construction of hydrogen infrastructure in Sweden is materializing, thanks to the previous experience gained from the different industrial sectors, as well as the EU and national hydrogen strategies. Renewable electricity capacity will increase to an extent that is sufficient to support all demands, including fuel production. We expect the BECCU policy to be in place by then, incentivizing the commercialization of electrofuel. Also, local airports now more equipped with diversifying infrastructure supporting the alternative fuels or alternative propulsion system. And finally, the collaboration between SAF suppliers across the Nordic countries will be strengthened at that point in time. Based on the scenarios and the expected technical limitations at 2045, we expect the Swedish aviation energy system to be comprised of 3 different segments, namely the first, short-haul segment covered by battery-driven aircraft, mostly servicing northern Sweden. Medium-haul covered by hydrogen-fueled aircraft, and the long-haul covered by SAF. Now, to illustrate the cross-consistency checking concept, we just look at part of the scenario, which is the long-haul travel done by 100% SAF fuel. So by deriving some factors from the scenario, and these factors are those that affect the production volume of SAF, rearranging them, we find several compatible relationships. For illustration purposes, we only look at the 2 extreme compatible solutions we found, which is the first one, assuming very large volume of SAF produced locally in Sweden with little need to import, and second is large import of SAF with little local productions. For this scenario, we also keep in mind that there will be potential limitations in the SAF supply chain in the destination country in 2045 when we are talking about a return flight. So meaning the inbound flight into Sweden may not be powered by SAF. So with this revised scenario and data, now we look at the revised LCA scope. So now we consider from the well to pump stage, either we will monitor the large-scale local SAF production or large-scale import SAF. And from the pump to wake stage, we consider the entire return flight is powered by SAF fuel, or the outbound flight by SAF fuel, inbound flight by fossil fuel, contrasting to the conventional aircraft flying the entire return flight with fossil fuel. So for data collection, we'd be interested to collect data that's on SAF production technology in Sweden, as well as other Nordic countries. Also, we would need to look at data that's for the upscaling of both fuel production technology as well as the underlying technology.
2 minutes remaining.
Thank you. We'd be interested to also follow the development of EU policies and IPCC recommendations concerning climate impact of biogenic carbon at the year 2045. As for the background data, so we'd be interested in collecting electricity mix both in Sweden and global average at 2045. Also, the road and oceanic transport at 2045 in terms of transporting SAF and fossil fuel into Sweden. So to summarize, by integrating LCA with the socio-technical perspective, we are expected to gain better understanding of sustainability of transitions by capturing impact of the underlying technological processes and also impact of technological upscaling, as well as potential burden shifting phenomenon. From the LCA perspective, we are expected to gain better insights into the influences of other sectors, potential impacts of alternative solutions, and potential impacts of a system that depends not on one but multiple emergent technologies. So with that, I wrap up my presentations and thank you very much for your attentions.
Thank you, Celeste.
Thank you.
Yes, Aleksandar, will you take over? And
Microphone again. Hello. Yeah, thank you for your presentation. Is there any questions from the audience? I didn't see anything so far in the chat. Is there good morning? So if you have any questions, just please type in the chat or ask directly. In the meantime, maybe a question from my side. What I saw is liquid H2 for medium haul flights in 2045. Did you do any analysis on which propulsion technology is actually being used to provide or to use in combination with the liquid H2? Or
For this, to answer your questions, for this analysis, we have not gone that far yet. Yes, we are aware of this alternative, either directly use liquid hydrogen or fuel cells. But we will expand on that definitely.
Thank you.
It could be a mixture of both or many others.
yeah, I can also ask a question to you expand a little bit from what you have seen from both socio-technical systems research and LCA research. What do you see as the major ways of enriching each other? What do you think traditional future scenarios in LCA might be missing that socio-technical system research will help you with? And even though this is not a transitions research conference, what do you see as the most important things that LCA could enrich that field of research with?
Yeah, definitely. That's the mutual. I would say both fields get help from each other. For LCA, with the transition research, I would say majorly, or the other way around, for transition research, like I said, normally if you look at a technology from their perspective, so here we have liquid hydrogen technology is supposedly to be sustainable. So let's look at how we can implement it in the large scale and which pathway we should take. But then the rest of it, what's underlying the hydrogen technology? How do you produce it? Is that sustainable to produce it one way or the other? That's no questions about it in the field. So we just take it for granted. This technology is introduced as sustainable, so let's continue to explore the pathway to get it deployed into the society. So in that way, LCA have to either strengthen the belief that it is sustainable for the particular technology, or provide more information for them to look at there might be alternative pathway that could be more sustainable than what we are trying to do here. So yeah, that way I believe it would help a lot.
So we have two questions from the audience in the meantime. One from Anna Salles, who's actually a speaker, so she can basically, just unmute and ask a question personally, because she's asking about an indicator, and I'm not quite sure what she's aiming at, so maybe she can elaborate.
Hello, good
Please go
morning.
ahead.
Celeste, you showed one slide about your indicator before you showed the graphic, and I'd like to learn more about it. You were talking about how you're going to compare this. What is your results? I think it was a third and a fourth presentation. If you can share your screen again. Because you have the target, you want to evaluate. How are you going to evaluate? This is what I mean. What is going to be the parameters for you?
Do you mean the slide for the LCA scope?
We cannot see your screen. If maybe, or are you sharing your screen?
I can share. Just give me a second.
Because you are including the social aspects as well, and with the environment. I would like to learn more about it.
Are you talking about this one?
No, the next one, the fourth.
This one?
I don't, the five. I don't remember, but I remember that
the graph.
No, I don't know which one.
This one?
Actually, my question is how we are going to. What is the parameter? How are you going to compare to have this? You get your results. It's more a concept, the quality. Or are you going to? This is. It's not clear for me. How you are going to conclude this? So to compare, to put everything on a boat. So do you have like a matrix of that you say, okay, this is more important? So for the aviation industry, is the social or the environmental? How are you going to measure this? This is it.
I think I understand your questions. So more or less, actually, the technique here is how to develop how you evolve into the future. So as I would be doing an attribution on LCA, so at one point of time here, 2045, that's where I want to do the assessment. And at that point of time, so why do I choose certain technology that I want to do the assessment, right? So that's based on this development of this society and the different rules or regulations that comes in, and that dictate what I'm going to choose for my future scenario. That's what this is all about. So I will probably not measuring anything from the society, but that's the society that's driving us going into, well, look, we need some import of the SAF. So if I do a traditional LCA, I probably just focus on large-scale production SAF in Sweden, but not thinking about, okay, I need to consider part of it is actually coming from somewhere else because there's not sufficient feedstock A or B to produce the amount of electrofuel or biofuel based on whatever regulations that we are looking at, etc. So that give me the directions where I go before I can put it all together and compare with the fossil fuel. Okay. If I answer your question.
Yes. Thank you very much.
Yeah.
Then there is one more question, but to keep to the time schedule, Aleksandar, should we keep that question?
Or maybe I think this one is quick, I guess.
Okay.
I think we can quickly do it. So Mikiaki is asking, or first of all, thank you for the nice presentation. And she's asking which kind of feedstock, I think is the question, you would use for your large-scale SAF. Is there a clear picture yet, or is this still in development?
Still in development, but preliminarily we are looking into forest-based feedstock for Sweden, as well as the electrofuel components. All right.
Okay, so I guess this answers the question, and we come to our next presentation. Yeah, Anna. So I will shut up and turn off my camera.
And I have to
You.
just a second to share my screen. Can you see now? Hello?
No, not yet.
No, I think, but we see the LCM.
Oh,
Next.
it's weird. Sorry.
Are you sharing from the content library or from your computer?
Actually, I put the share, and then I click on the to share the entire
Screen, yeah. And I think then you just have to bring up the PowerPoint.
Yes, and then
You can share from Windows. Instead of sharing screen, you can share window. We're now seeing your screen, so there would be like...
Now, if you open PowerPoint now and bring it to the front, I think we're fine.
Now?
Yes. Yeah, it's good now.
Really? Okay.
Yeah.
Okay, so I put on the models presentation. Can you see now?
We can see, yes.
I guess you can see this here as well. So
yes.
Can I?
Oh, you can hide it, I think. I think you can hide it. If you click Ausblenden.
Ausblenden. Oh, okay.
Yeah.
I was scared.
Perfect.
Okay, sorry for this is the first time that I'm doing this, and I guess most of you, so we still have to learn. Okay, so good morning, everybody. My name is Anna Claudia Nioacta Salles. I work since 2009, as Aleksandar already mentioned before, so at the Fraunhofer ICT as an LSA expert. And I would like to present our work in the Clean Sky project from the LSA team. Capgemini and the Universities of Stuttgart was also involved in this project that we are still working on. And I'm talking about the new life cycle inventories that we have been creating from the Clean Sky Airframe technologies. And so the Clean Sky program started in 2008 with the first part of the until 2015. And now we are currently in the Clean Sky 2. So from the 2015 and goes up to 2024. And the Clean Sky is the largest European research program for the aviation industry. And they, in the Clean Sky, there are a set of goals, environmental goals, as you can see on the screen, and where the new technologies have to reach these goals. And we are working on the aviation and the creation of the Clean Sky Aviation Environmental Database. This database started in 2009, and so in the Clean Sky, the first part of the program, and at the end in 2015, we had 109 technologies only from the airframe part. And we have with this database, so they are mainly from gate to gate and processes, and with this enable us to do the life cycle assessment for the demonstrator level. So the airframe parts, so fuselage, so wings, and the seats, so also the interior parts. And Hannes Krieg, the moderator of the LCM, also took part of this first part, the creation of the environmental database. And let's move on here. And now this work, so Clean Sky 2 has changed a little bit. So we have the three main demonstrators, so large passenger aircraft, regional aircraft, and the fast rotorcraft. And then and divided in the three platforms, airframe engines and systems, where the technologies and the demonstrated have been developed. And this interface between the eco-design where all the LCA data have been delivered, and to the eco-design platform led by Fraunhofer, which the eco statements or the LCA for demonstrator level have been performed. And so this work is a part of the airframe, so the work that I'm presenting today of the airframe platform. And it calls Ecotech, and the partners you can see on the screen. And so Capgemini and the University of Stuttgart and Fraunhofer collected the data from the partners, so the industry partners, from the industry, and also from the advanced research institutes. And the main demonstrator that we are working on are from the cabin interior, such as drawer box, handrail, and the seating structures, and the fuselage panels, and the wing. And when we wrote the abstracts, it was about 80 LCI stars. And now today we have complete 114, and we are working to increase it even more. And so we started with 109. Now we have more 114, and we want to continue this work. And for you to learn more about what specifically are those new LCIs about, so for the metal and surface treatment, for the production of fuselage section, there are the lighter metal alloys. These are not really from gate to gate, but from the production of the new metal alloys. And from gate to gate, we have the new manufacturing technologies, the improvement of some of them or the new ones. And for the surface treatment, we have collect data for those which are avoiding the use of hazardous elements. And for the thermosets, where for the production of a stabilizer panel in tailplane, for example, the data are about the new curing processes and the manufacturing of some new innovation. Yeah, a lot of innovation for the manufacturing technologies, and the local self-healing treatment. This is quite new. This is a very instead of changing the entire part, so just specifically, so just repair the part damage in this entire component of the aircraft. And for the thermoplastics, we have fiber placement technology, so improvement as well, and innovative welding technologies. This is quite very important, and specifically for the use phase to make lighter the part, and more technologies also about the recycling. And for the left hand side, you can see a frame of a window made of recycled CFRP, and the application of recycled material. And the last one is the biomaterial. And so in this one, the natural fibers. So this is also used to produce a drawer box, for example, and the bio-based resins for the seating production, the foam, and they have shown good results for the avoidance of they have retardancy, the flame retardancy properties. So this is quite good instead of using chromium, chromic materials. And the new material systems as well, for the application for the production of these parts, and the new foams with improved fire retardance and less toxicity, which is required for the REACH. And this is for the production of cabin elements such as you see in the picture. And conclusion, what is very important for us is the continuation in the creation and the extension of this Clean Sky Aviation environmental database which allows us in the industry to perform, to really to introduce the eco-design concept before and now during the eco-design phase. This is one of our main role here, is to support the aviation industry in keep track on that, to consider this, to increase this environmental awareness. This is something that we, in the first part of the project, the Clean Sky, it was more about to learn each other. So the LSA experts and then the developers of the technologies, the parts. So really, so two separate works, and then we learn each other, and we have a lot of lessons learned. And now in Clean Sky 2, we are improving that, and this brings us to since we are direct in contact with the aviation industry, the partners, we can produce a database with robust and good quality. And one of our main challenges are we are talking about, we are also comparing them with the reference technologies, which are in TRL 9. And then we are working and collecting data that are about sometimes 3 or 4, but most of them, they have to reach TRL 6, which is better. So this is something that we are facing on and working on to improve. And this, if someone on the audience wants to talk, to discuss more about this, because this is something that I would like to bring and share with you. If you have an experience, we can talk more about this. This is one thing. And also Celeste was mentioning the data that you are using on. I think it's very important because the data is the core of the LCA. So we all know about this. And so this is, I would like to talk, if we have the chance to discuss more about this. From your experience, if you can, tell me, and maybe we can share about this. And so this is our main contribution. This was from my side. That is just to close, because so Clean Sky, as Anna mentioned in the start of the session, I have written here just a second that the transformative change needed in mobility to reach urgent climate targets. So this is very important, that we support the industry to say, oh, yes, this technology has potential to contribute to the aviation industry to reduce the environmental impact or not. We have found in this meantime a very interesting thing that they...
Sorry, I forgot to announce 2 minutes remaining. So we're now out of 10 minutes.
Okay, so we are out. Okay, so
it's my fault.
Actually, I thought I was waiting for that.
Yes, I'm sorry. I saw your conclusion slide, so I wasn't going to interrupt you. I'm very sorry.
No, okay, but I'm done. That's why I was talking. I was taking advantage of my time. I thought this.
I understand.
But thank you very much for your attention. So I'm glad to discuss with you about the quality and this challenging in producing, creating LCIs from the lower TRL. So this is what I would like to take advantage of talking with the LCA expert here. It's quite great. Thank you.
So I think you're still sharing your screen. I don't know how you unshare now. But we have... that's what you... But in the meantime, we have 2 questions from the audience already. So one is from Celeste, actually, who did the presentation early on, who was asking whether this database is actually available to the public as well, or whether it's just available to aircraft manufacturers.
Yes, this is a very, very good question. Thank you. Because in this 109, there are 70 parties that this data belongs to. So, for example, Airbus, and that they share with us their data. And up to now, this first part is version of the database belongs to this party. And I will check this because I guess now we are able to sell them. I will check. Please, I will write your email or find out, and then I will answer you. And then I don't know how this is under discussion, how we are going to incorporate for example, this 119 and the other database that are complete. This is still under discussion. This rights is very complicated because it involves the entire everybody that is delivering us the data. It's quite complicated. But thank you very much. This is very good because I can bring this to the team and then to find a solution to speed up the solution.
Then there is a second question which I would like to combine with a question of my own, maybe. So the question is, how much of the environmental impact of the life cycle of an aircraft is actually attributed to the production stage? And with that context, so basically, if you look at the life cycle, how much is production, how much is use, how much is end of life? And in that context, my question is, if you look at these inventories and especially at the new technologies, I assume most of it will be weight saving, or is it also lifetime or maintenance improvement? So what's the main focuses of the dataset development and the manufacturing technology development here?
Yeah, thank you. It's also a very good question. So yes, mainly from the use phase for sure. We are working on the instead of the use phase. Use phase, there is a special platform where they're gonna get our data, and then they create the data for the use phase to get the results. But for sure, the main impact comes from the use phase. And our main target, as is you already mentioned in your question, is the light structures, because we have to make sure that they are not adding, because sometimes there's also you replace, for example, welding, but use for the lighter material, but you need something extra for the structure. So this we are also supporting them. And but the main idea is stop just to think about the use phase, because it's focused on that, and it's maybe not easier. But if you see, we are now tracking also the assembly line. There's also the intention in the future to track the effort in the airport, the taxing, so the logistic is very, very complex. And we should start think on that to eco-design. This is our main target. So the Clean Sky program to increase the recyclability, not only focus, okay, use phase, doesn't matter, is it lighter or not? And then with our fuel, for example, as well. So let's not talk about the manufacturing phase. No, they want to increase this. And we have seen as well with the contact with with LCA, the environmental, the industry have also increased their awareness on the environmental aspects and started to incorporate that. And this is very important. But for sure, it's up to now in the Clean Sky 1, we showed 95% is a use phase for sure. But as I said before, this is a stop, think on that, and thinking on the closed materials, circular economy, circular of the materials, increasing the recycling technologies, and also the manufacturing to improve, optimize. We have seen there is a lot of potential improvements needed, and they are working on.
And maybe a remark what I remember from my past when I did once a study on aircrafts is, of course, the use phase is overwhelming. But there is also, let's say, and lightweight design is the most important thing. But what if you look at how pieces or components are manufactured for the aeronautic industry, the scrap rate is enormous. So where normally in a traditional manufacturing environment, you talk about a scrap rate, and then you say, okay, we have 50% scrap or 60% scrap. The aeronautic industry actually talks about the buy to fly ratio, which means they buy 10 times more than they actually fly. So the scrap rate is larger than 90%. And so there is also a significant potential in the production stage or in the manufacturing stage of these processes.
Yes. Thank you for your comment. Perfect.
Yeah.
Yep.
Okay, thanks. We have scheduled a short break here. I moved it 5 minutes ahead, but we still have time to fit within our time boundaries. So let's meet here again at 10:35 for our next presentation.
So, is everybody back again?
I think so. I hope so.
Good. Then I think let's reopen the session with the next presentation from Aleksandar Lozanovski about powertrains in the year 2040.
Thank you very much. I hope you can see my slide. So,
It's yours.
I will give a short overview. So we are talking about scenarios for future development. So when I'm talking about the year 2040, we are not only evaluating some parts of the system, but we try to evaluate many parts of the system towards the year 2040. And that's what I'm trying to show you in the next slides. So what are we talking about? First of all, we have 3 different vehicles. A sedan car, which is rather a small to mid-sized sedan with an empty weight of 1.4 tons, and SUV with 1.8 tons empty weight, and a light truck, as it's often used, let's say, regional delivery, with less than 7.5 tons maximum weight, as it is very common in Europe. And as said before, the focus is on the year 2040. So we are talking about technology developments. How will the future drivetrains look like? How will the future consumption look like? And we have a project partner for that who is simulating future consumptions. We have various powertrain concepts from mild hybrid, full hybrid, towards plug-in hybrid, battery electric, FC, range extender. So a bunch of various powertrain concepts combined with a bunch of various fuels, synthetic gasoline, diesel, SNG, hydrogen, electricity. So in total, 57 variants, which we're taking a look at. One very important question when you're looking into the future is, how does the future electricity look like, especially as we're talking about synthetic fuels and battery electric vehicles. So we went on and took a look on how could future electricity look like, and we realized there is not one answer but many. And one answer is, if we look at, let's say, future renewables which are newly built, it's here an example in the year 2050, might reach as low as 5 grams CO2 equivalents per kilowatt hours. That is one part of the answer. The second part of the answer is, if you are conservative and say there are no further measures for future electricity system, we might also be above 200 grams CO2 equivalents per kilowatt hour electricity. So to have the possibility to show various things, we said, okay, let's do a range. So we're evaluating 5 grams CO2 equivalent and 230 grams. Next question, what happens often in studies looking to the future is that they use nowadays LCA databases, make the production for a vehicle, for example, and then evaluate future consumption. But also, most likely, the production of the materials will change in the future. So as we could not do, let's say, a really great look into it, how the future materials...
Presentation is hanging. Or are you still on slide 4? I think you changed, right?
Okay, now slide 5?
Yeah, now it's fine.
Okay, thanks. So how about future materials? And we said, let's do a simpler way. We are having the valuation for the electricity already. So what happens if we take today aluminum production and just replace the thermal energy and electrical energy by renewables? What will happen to the environmental impact or one potential of the aluminum production in this case? And this is the example for aluminum sheet. So first, we're looking at today mix. Then we replace the thermal energy and electric energy. And just by replacing the thermal electric energy, we have a total GWP reduction of 78% less. And this is what we did for, let's say, main materials in the vehicle. So any single vehicle has, let's say, at least 60-70% of the materials switched to a future or more. So we looked at it for aluminum, steel, lithium, nickel, manganese, platinum. So it depending on the material, the savings by using renewable electricity in today's material production is 20 to 90% compared to today. So also at this part, we try to look, how would the material look like in the future? Status quo about the results, setting the scene, what the results are about. So as we are halfway in the project, the result of the production and use of the vehicles are only partly final. Some parts, let's say the battery size, will be adjusted finally after the consumption calculation, because we said we have fixed range, any vehicle has the same range, and after the consumption calculation is done, we will fix the battery size likewise, also like the tank sizes. So the results on the next page is a rather order of magnitude where we're looking at. So now the system itself, when I click on the next slide, shows me that it's working. I see the nice round thing which changes, but the slide doesn't change. Okay, now hopefully you see nice slide number 7, a nice graph. Okay, very good. So how would the results look like when we are looking at a sedan and 5 grams CO2 equivalent per kilowatt hour? And what you can see here, that we have the same base vehicle for every vehicle. We just exchange the powertrain components. Obviously, same result like today, higher degree of electrification, higher, bigger battery, the higher the results. Let's say the gap towards higher of the batteries gets smaller in the future due to the case that we evaluated also future battery technology, so higher gravimetric energy density and volumetric energy density of the batteries and also future materials. But still, this gap remains. So a battery electric vehicle has, in the production of the vehicle, a higher impact compared to ICE combustion engine vehicle in this case. What was also quite interesting is that you see the CNG tanks, the carbon tanks, which are also visible here, adding also part of the powertrain. Now you will see the same slide, but with 213 grams CO2 equivalent per kilowatt hour. Obviously, also the production of the vehicle changes. As I explained before, we have the materials and we replace the electrical and thermal energy demand with the, someone is clicking on my slides. Thanks. And we exchange also the electricity demand and the materials. So obviously, when we have 230 grams CO2 per hour, the results are higher compared to 5 grams CO2. The overall picture remains the same, but the results basically are higher now. So these results are good for order of magnitude, as I said, but not final yet. How about the fuel production? So again, we're talking about the year 2040, we're trying to evaluate. So we took a look at future projections for synthetic fuel production. On the one hand, with the battery electric vehicles, you have high production efficiency and you have some losses, which you see in the charging efficiency. And for hydrogen, methane, gasoline, and diesel, we evaluated expected future efficiencies of producing the fuel, and also including, let's say, liquefaction transport if it would be done in MENA. So the electricity for the battery electric vehicle and the electricity for producing hydrogen centrally is sourced in Europe, and methane, gasoline, diesel are produced in this evaluation in the MENA region and transported to Europe. This is the expected scenario for the year 2040. Using these efficiencies, combining them with our electricity, what I said before. This is the first results. Obviously, you can see the battery electric vehicles and some of the variants miss already. But what is visible when we talk about such a low global warming potential of the electricity, the production of the vehicle gets really important. So
2 minutes remaining.
Thanks. So in future, we have to spend even more effort on taking a look at the production of the vehicles and also evaluating expected future productions when you're talking about 2040, 2050, whichever kind of data. This is the same result as on the last slide, but I changed the y-axis because now comes the results with the 213 grams CO2 equivalent per kilowatt hour. The production of the vehicle is still the same, but obviously the use phase.
You have to jump back and forth again. The slide is hanging again, unfortunately.
I'm sorry. Now? Do you see the slide number 12? Okay. So obviously the use phase of the vehicles gets way more important at 230 grams CO2 per kilowatt hour, though the production is still visible. But one thing, this yellow light bar, which hopefully everyone is seeing because the slide changed, is indicating the range of fossil fuels. So if we talk about the future at 213 grams CO2 equivalent per kilowatt hour, we emit more GWP emissions with synthetic fuels than we would do with still using fossil fuels. So this brings me to the conclusion and to the next result that first of all, we need really low renewable, a high amount of renewable electricity for a low GWP electricity provision. Otherwise, synthetic fuels and other measures are not really worth it. Depending on the scenario, if we reach a really low GWP of the electricity, then the production phase of the vehicle gets really important. This is another result where you can see here that the today picture, the production makes only some part of the overall life cycle, might change in future when we get to lower GWPs. And to summarize also, more powertrains concept will be validated soon, so this is work in progress. And as I said before, various vehicle concept, totally 57 concepts, and the results will be published in open access report, and this will be planned mid of next year via the FEV. So the Forschungsvereinigung für Brennstoffkraftmaschinen, the research on internal combustion engines here in Germany. And this will be a public report written in English. So I'd like to thank you. And if you have any questions, please let me know. So I can see there's one question by Celeste about the future material process. Right now we have, for most of the materials, we only took a look at replacing the electricity because that was a simple way getting into the future and getting good results with, let's say, limited effort, because we cannot do in this project large things. Only for steel, we evaluated steel mills with hydrogen because obviously in a steel mill and a blast furnace gas, the share of electricity-based GWP is really small. So for steel, we assumed, I think, 70% less GWP in 2040, based on that most steel mills will have already changed towards using hydrogen. Any more questions?
Yes. Well, maybe a remark. I have done a similar thing in the past, let's say. For steel specifically, or for other materials, I think it's the same thing. What my findings were, if you basically transpose everything into the future, and well, depending on how carbon neutral you assume the electricity in the end. I mean, if you basically, I put 0 in because I said basically if I can get the electricity free of charge, I can also produce the materials free of charge. So if I then look into steel, what I find as a remaining CO2 emissions is usually all the minor constituents that basically are adding up to 5-10% today, like the auxiliary materials, which are then basically driving the emissions. But wouldn't I need to assume that also these materials will change in the future because their electricities and energy supply chains will change as well, which would lead to a much larger CO2 saving than is actually anticipated?
That's a very good point. We discussed it in the project. So when depends on which material you look at. With some materials, like let's say steel, you have CO2 emissions which get out of the process. For aluminium, all the remaining CO2 emissions are mostly because of the reduction of the aluminium oxide producing CO2. So a technology change is changing most of the GWP of the materials, and the remaining materials should also be changed. But to do so, the question is, let's say, effort versus results. In theory, you're right. It would be way better changing, let's say, the whole database towards future materials, future production of for materials, and expected future electricity. That would be the best way to go. But let's say, in terms of really doing it, kind of difficult.
Yeah. Well, my conclusion was, because also the limited resources argument I totally follow, was it's actually more interesting to, rather than looking at the CO2 emissions, because you can basically skew them with the electricity as you like, essentially, is to look at the electricity consumption or end energy consumption, really. So because most of the energy will be replaced by electricity at some point, even the thermal energy, which means if you basically do an end energy balance, let's say, and look at the end energy, you can also get a feeling for the comparison of the two systems and see the energy efficiency, and you basically avoid the masking effects that you have, basically, because all the technologies are carbon neutral all of a sudden. And
You're
I
fully
assume,
right, I agree. But the question is here, do you evaluate the kilowatt hour source in Europe the same as the kilowatt hour source in MENA, where, as most people say, more is available? So that's a question which remains in this perspective, because let's say Germany and Europe will still remain an energy importer, most likely also in a renewable future. And then the question remains, does the kilowatt hour in Europe and in MENA has the same value?
that's interesting.
So I guess we can hand over to you for the last presentation.
To me, yes. So 1 second, let me pull up my presentation, maybe in let me just see how I do that most efficiently. Bum, 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 bum.
And your camera would be super nice.
Yes, let me try. Yes, screen. Do you see my screen? Yep, should be okay. Let's do full screen for everybody. So everybody should be able to see my screen in full now. Is that correct?
Yes.
Well, I can't see anybody's, so maybe an oral feedback would be good.
Looks good.
Good, perfect. So yes, my presentation is about integrating design for environment to achieve carbon neutral mobility. And in essence, what we've done in the past, so is kind of a lot of similar studies than Elle just presented in the presentation before. So we looked at battery technologies and improvements, especially with my former employer IAV, who also contributed a lot of the basic results that we've used to come up with this study. And we've asked ourselves, what actually does this mean for an entire fleet, and and how can an OEM actually employ that kind of information and apply that kind of information usefully to manage CO2 targets? So maybe this slide to take off, we are currently in kind of a predicament that the European Commission, or basically we all have set ourselves the target to reduce global or GHG emissions by 95% until 2050 compared to a 1990 baseline. The challenge, as we also announced in the previous slides, is that actually we didn't go in the right direction in the past couple of years, but rather increased compared to 1990, then decreasing. That's actually true across all transport or means of transport, so including aircraft and passenger cars and everything. Yeah, and on the other hand, we are in the situation that we're actually let's say, reporting kind of achievement. So we basically reached a fleet consumption of 120 grams per kilometer. Or the automotive industry, let's say, has introduced hybrids, engines were downsized, downspeeded, electric vehicles were introduced, and now we start basically announcing that fleets will be fully electrified, and there is also CO2 targets and goals basically being announced by OEMs, like minus X% by 2035, or we are going to be carbon neutral by 2050, minus some number of years, which ranges between 5 and 10 and 12, and so depending on the OEM, the X can be a different number of years. And to do that and to assess that, we are actually calculating a scope 3. And what I want to do is basically want to look at the method, how we calculate scope 3 today in comparison to what we need to be doing in future to basically make this graph actually go along the red line rather than going up here while reporting that we are doing everything fine. So the question is, or let's phrase it the other way, is the way we are currently doing scope 3 calculations in the automotive industry helping us to actually achieve this red line here, or is it not going in the right direction if we do scope 3? So let's have a look at how we do scope 3 calculations today. So what we typically do is we calculate an LCA of a vehicle. Then we go to our sales department, or we go to the sales department and basically get a breakdown of markets and segments and sales, and then we just multiply basically the results of the LCA with the markets and segments. We get a grand total. This grand total we sort into the different scopes. So scope 1 and 2 is obviously what happens at the OEM site. The scope 3 category 1 is purchased goods and services. This is basically the entire production stage of the LCA minus the scope 1 and 2. Scope 3 category 11 is the use, which is the use phase of the vehicle, and then we have category 12, the end of life. So it's just a different sorting of a scaled LCA result, if you like. So let's walk through this exercise and see what kind of results we would get if we take a sample OEM who is actually selling in 3 different segments in 6 different markets, and each market basically we assumed a development of the powertrain. So in this case, we only looked at 4 powertrains, diesel, gasoline, a plug-in hybrid, and a BEV, because these ones are actually the ones which make the most difference. And also we wanted to keep the study simple and not discuss so much about the numbers. That's why also everything is relative. And what you see here is actually let's say the resulting share across all markets of powertrains that have been sold. So we start with a fairly high share of gasoline. And then we introduce BEVs quite rapidly. And in 2050, we will only run battery electric vehicles in all segments and phase out all the other technologies until then. So something you should know and keep in mind as well is that these markets are somehow mature markets. So if you look at the European markets, they are hardly growing. The number of vehicles is more or less constant. If we look at China and India, we are looking at heavily growing markets, and we have year over year, we have more vehicles in the market. So we tried to capture that and assumed a 20-year lifetime for every vehicle, and we had increasing sales numbers basically in India and China, whereas basically the sales numbers in Europe were around constant. And if we look at the results and break them down into the life cycle, what we get is this. This is now a life cycle. So obviously what we see here is we get huge increase in the production stage, which is due to switching from gasoline vehicles to electric vehicles, but also is due to the increased number of vehicles that we have. And we also see that we've created a huge tidal wave regarding the use stage here in the middle. And we need to see that, or we need to keep in mind here that basically what we assume with our current methodology of calculating the scope 3 is that basically the vehicle as it's sold in 2021, we assume that all the emissions of the life cycle are basically happening in the same year, which means the whole life cycle is running in 2021. So this picture looks scary as it is, but the question is also, will this actually meet the red line? So if we basically just look at the tailpipe emissions, because there is certainly a sector shift, which is undesirable, but at least we can maybe meet the red line. We look at the next slide, and we have broken down these tailpipe emissions into the different markets we are selling. So if we look at the European market, this actually doesn't look too bad. So we have basically steadily going down until 2050. We also, maybe I didn't mention that before, but we also assume that, of course, the electricity grid mix is improving until 2050 and is, in a simplified case here, 0 in 2050. But we can also see that in these growing markets, we will basically reach the peak of the tailpipe emissions significantly later as the number of vehicles increases. So, but if we just look at the European market, it actually doesn't look too bad. We are basically on the red line, but are we really? And the answer is no, because what is this graph actually showing us? This graph is showing us the average of all vehicles registered. So basically taking our approach as we take it today to basically take the vehicles we produce, the fuel production, the end of life, and just taking that in each year where the vehicles produce is not going to cut it, because what happens in reality is that we have a vehicle that is produced in 2020 and it will emit CO2 for the next 20 years until it is finally disposed or recycled in the year 2040, which means we have a very long way to go with these technologies. And if we try to incorporate this into the simulation, the picture is looking a whole lot different. So this is the same image with the same new vehicle registration. So the light blue bar for the production is exactly the same. But what we did is we artificially built a fleet from 2000 to 2020, so that we have basically a current market split in the market today. And then we, let's say, wrote it into the future, assuming that every vehicle that is registered has a lifetime of 20 years, which means basically if we have gasoline vehicles being registered in 2030, they will be still running in 2050. And with the split that we assumed, we are actually seeing that we still have significant CO2 emissions basically on the road in the year 2050, and we are not meeting this expectation here. So what I'm actually aiming at is we should actually try to make our CO2 or our scope 3 calculations, like we basically explained here, consumption based. So basically looking at the fleet as it is in the market today and take these emissions into account, rather than basically assuming that the vehicle is produced today and running all its 200,000 kilometers lifetime in 1 year. Just because we then basically get the perspective of what actually happens if we are a bit too late in changing the technologies. And we have the advantage that we basically get a view that is somewhat consistent with what the regulatory bodies expect us to achieve. Another advantage of looking at it this way, although the savings don't look as enormous as they look in the other picture, is that most OEMs are aiming to become a mobility service provider at some point in the future, or at least aiming to do that. And if we look at this, this means we will be internalizing the tailpipe emissions and all the emissions linked to electricity that we have, because what is today scope 3 will be then scope 1 and 2. So maybe conclusions from the study. Let's say we will still have ICEs in 2050. There will probably no way around e-fuels or biofuels in some kind of form. And also, if we look at the production stage here, some kind of supply chain management will be needed. And this is actually what we've been trying to solve at Makerside, and in the sense that we build a platform, or we are building out a platform that does things, or that does use a bit of a different data model than a traditional LCA. So what we are doing is we introduced, next to the term flow and process, we introduced a product or a component, basically. So product component, we call it product in the software, but in the end, you can basically imagine it as a vehicle or a component. And then this component exists independently of how it is manufactured. So basically every component can have 1 or 2 manufacturing processes, or 3 or 4 or whatever, and these can be supplier specific. So you can basically ask your supplier for the manufacturing data of this component here. And then what we do to calculate the scope 3, instead of basically taking the LCA result and multiply it with the sales numbers, we go into the sites and the transactions. So we look at what these sites have purchased from which supplier, and then we can basically sum up the transactions and calculate the scope 3 of purchased goods and services, and the scope 3, let's say the usage, we will calculate of the vehicle sold still. But like this, we basically get a manageable account on the supplier data. And the advantages, since this is basically a digital twin technology which integrates with the systems, these data that we collected from the suppliers are also available to the design team. So you basically, if you do an LCA study, you have supplier specific data available. You can use it to calculate the scope 3. So we are looking at all the same data foundation, and we can make sure that there's basically no gap between the scenarios you calculate in the LCA and what comes out in your scope 3 calculation in the end, and what actually regulatory bodies expect from you. So
Remaining, Aleksandar.
yeah, that's actually it for my presentation. I thank you a lot for your attention, and any questions, feel free to ask. Good. I stop sharing somewhere. Where do I do that?
No question.
Here we go.
Q&A. Let's check the chat. Dennis' question, this is probably directed to you. Did you have a look at hydrogen and synthetic fuels?
Yes, well, we had not in this study of because we wanted to have a simple result, but of course we had I don't know whether this was maybe even regarding L, but we also of course basically did scenarios for hydrogen and synthetic fuels. I didn't want to present it here because the time frame was so short, but if you are more interested, we have done a similar presentation, not with the perspective of an OEM and not so much with the perspective of making it actionable, but my former employer, IEV, I must say in this case, did a presentation last year at the Vienna Motor Symposium on last year and the year before actually, on how this applies to fleets. And then there were scenarios regarding improvement of engine technologies, different fuels, fuel cells. So there were all sorts of technologies included. So there is much more there in much more detail, because the presentations were like a 1 hour slot or something. So there's much more depth available. If in the best case, you can also ask my co-author Christoph Danzer for more feedback on that.
I just want to ask you, what's your spontaneous reaction to upcoming regulation or existing of prohibiting fossil fuel vehicles from 2030?
The question is, well, the question is, do we prohibit the sales on or the use? That's one thing. So the question is what we talk about, and also we have to consider that we are basically always talking about a worldwide market. So what may work in Europe needs to be working in China and Brazil and all the other emerging markets as well, which is more of a challenge. So as you also saw maybe in the slides, what basically drives the major CO2 impact is not the European markets anymore. It's what's happening in China and India. So yes, maybe. So I doubt it will change much.
Yeah, there's this tidal wave. It was a good illustration of what's going on and will happen. If there are more questions, please. Yes, there's one from Anna, I think. I can read it. Or you can post it yourself, Anna.
I would like to learn more about, you mentioned that the foreground database you are getting for the suppliers and the customers, and from the background database, which one are you using?
So in this case, we build on previous studies that we have done with IAV, that was Gabi. In MakerSite itself, we are using EcoInvent. So if we would remodel it, it would be EcoInvent based, which which is just basically, or not necessarily. Well, no, that's wrong. Actually, we mostly use EcoInvent, but we have basically lots of databases included, and we can include several databases. We prefer EcoInvent to a certain extent because it's easier to do these supplier engagements, because all the data is unit process based. And what we have in the tool is essentially a possibility to convert a unit process directly into a questionnaire and send it out to a supplier. And then you basically get the result back. You have a copy of the same process, and you can just replace it in the whole system and see what it does with the supplier. So it's not about data quality in this case, but rather because the transparency makes it easier to manipulate the data and
handle
engage
them.
with the supplier. Yeah.
Okay. And in case you have like an innovative process, I don't know if you are dealing with this, or you work only, get only the data from the TRL9, or even in other projects, if you have worked with less TRL, are you using Aspen program or software, something else, or how do you deal with this?
So theoretically, there is the possibility to go down several tiers. What we are looking at, because we're not implementing the system with the automotive industry yet, we are currently implementing it with a customer from the renewable energy industry. And he actually aims to ask his suppliers with the tool. So he will probably start with the hotspots, of course. So we'll basically go and work with the biggest contributors to the Scope 3 footprint. And the first step is basically to get more accurate data than basically applying average LCA information. And the second step would be to engage with the supplier also to identify pathways of improving the system together. So it's nothing that you can be pushed from top to bottom. I think it needs to be done in collaboration, as the development of components is done basically in almost any industry. It's not a the OEM develops and the other one just produces. It's a joint work where the development is carried forward together with supplier and OEM in the end.
Okay, thank you.
Okay, are there any more questions out there? I would like to ask for comments from all the speakers. If you attended the keynote in the lobby in the beginning this morning, I think it was quite a lot about footprinting, keynote from Pre-Sustainability, but apparently LCA is so much more than footprinting of products to inform consumers. And this session was about transformation, which is a much larger challenge, using LCA to assess transformative processes. But you who are trying to grasp the bigger picture with LCA, do you feel that LCA provides the tool that you need to assess the larger transformation and the questions that we need to answer to take strategic decisions? Is LCA actually able to provide that help, or maybe we should just go ahead more based on intuition and the details that we know? And sometimes when I listen to you, it's overwhelming with uncertainties with data from the detailed process and technology and material level to the future scenarios. And it's really interesting to do that kind of research. But do you feel that it's also possible to do it in a meaningful way? Any comments from the four speakers?
Maybe from my side, I mean, we came up with this approach to a certain extent because these uncertainties are always there if you basically do a study in the present day, and then they clear up over time. And I think it's important to see or to track in direction of which scenario you are leaning, and then you can basically see when things get out of bounds. And that's why this approach with the digital twin is what we are striving to implement. And also basically doing these scenarios and planning ahead is like in German we say die Rechnung ohne den Wirt machen. So basically you plan ahead and you don't look at the customer. So basically the market will always prove you wrong in the end. And you have to adopt very spontaneously, and you can basically make all the strategies you want. Whether they come true is a question that is on another leaf, and you have to react what the reality proves to you.
I personally, of course, am in support of using LCA for strategic decisions.
Yeah.
Students come to my courses to learn product LCA and footprinting, but what they need to do is to use LCA for strategic purposes. But then when you start doing that, it gets overwhelming. So it's, it's not an easy thing. Anna, Salles, did you have a comment?
Yes, I totally agree with you both. The LEC, I think it's a very good tool to support, at least to see the tendency. I think this is very important. Sometimes depends on the certainty, and I always like to present the results, saying that this is don't see exactly sometimes the absolute value, but even the relative can be quite complicated to interpret it. So we have to be very carefully, and but to see the tendency and to bring also this concept, because sometimes they think, oh, it's green, biomaterial, it's green, that's it. But where this material comes from, what happens with the product, what is the production, what is the logistic? Do you need to add something? So this really when we are talking with the aviation, are we talking about the entire aviation? But if we are lighter aircraft, they're producing lighter aircraft, but if the fuel are going to increase, what's going to happen? Are we talking about aviation or aircraft production, or during the operation? So it's something that I think LEC brings to the question. The phase one, I think it's very, very important to take time when doing LEC, and that the technology expert can start to incorporate this during the eco design. So I am a big fan from the eco design and this circularity concept. So to bring into this message to the engineering department, that say it's also of course very important, but they have to start opening their mind. So, and the LEC 2 is more concrete, and they can better understand our language, LEC language, I would say.
Yeah, thanks. Celeste, did you want to add something?
Yeah, definitely. I agree with all of your comments, and I also think it's very important at this point, at least to produce something to or create a discussions and beginning to look at it. But I think also two things are very important. Everything we are doing for the future, we need to be very transparent. Whatever assumptions we are making, we need to make sure whoever is reading the report understand where we're coming from, so it will not be misleading. And also as well, I personally think that it's lacking in the field that nobody really go back to look at the LCA results that you have performed a few years back. Things change so quickly in aviation or transport. So maybe every other year, the one who's responsible for it or whoever is continue with the research work should look at what has happened, what we have done. Maybe something need to be changed, and there will be a new set of results. So yeah, that would be my thoughts.
That could be a research field in itself, LCA data mining. Annika Lövgren posted a question. Does any one of you have experience in coupling LCA with system dynamic approaches, tools, or software in order to try to capture systemic impacts / transformation potential?
I think that we're looking at the consequential LCA. I personally don't have experience here. I don't know if anybody has from the speakers present. No. Maybe also a remark from my side quickly to what Celeste just said. I also think it's my personal opinion here, but I think LCA is not a particularly good tool for labeling. to be completely honest, because I think it's great to have a foundation to build a discussion, and based on the discussion build a strategic decision. It doesn't have to be a report, but there should be a discussion about the boundary conditions, and there should be scenarios played with. If you just put a number on the label, I don't think it's worthwhile, because you always cut the story short. I mean, it's difficult to do a simple example in the automotive. Oh, well, maybe one in the automotive industry is what you could do is, for example, if you look at the carbon footprint of an electric vehicle, where you basically have the production, of course, the electricity and the usage that has certain CO2 emissions, but you also have additional potential for smart grid applications and things which are not captured in a direct comparison between, or difficult to capture at an LCA today, and also in a direct comparison with a gasoline vehicle. At least if you just want to print it on a label. And the same is, for example, true if you look at fast-moving consumer goods like food. I mean, there's one aspect is what's the carbon footprint of the packaging on the product with the packaging, but the other aspect is what's the shelf life? Is there maybe, so the question is, what do you look at? So if you look at a cradle to gate footprint of a product, and you say, okay, product A is better than B, but if we throw half of it away in the supermarket because it rots faster, then there is no help in it. So basically, if you start going from an LCA report to a label, there is often either you basically run into limitations because the rules are so strict that you basically your design is limited, your design options are limited, or you're basically leaving out half of the story and are maybe optimizing for the wrong thing in the end.
And still, labeling is what's creating the surge for LCA right now. So that's an interesting comment. We need to wrap up. We're already running over time. Or did you want to add something,
I would like to add something on what Alex said. This is a very, very important point, because the energy system changes every single year. The environmental impact of vehicles changes year. Production changes fast. So I agree very much on this point. We need to do an LCA any other year, again and again. But I don't see a better tool for providing labels, though those labels are incomplete. So what is the question? Shall we wait for the perfect thing? Should we have let's say, a digital label which changes every other month, or what would be the solution to that? Because I don't see a better way to do it right now.
Yes, that's true. Yeah, if we're going to label, it should be with LCA. We need to wrap up. Thank you, everyone, for presenting and attending. And we had many more submissions, of course, to this session than we were able to give space as oral presentations. And I would like to encourage everyone to look up the poster presentations. Some of them, I think, are only visual, and some may have a recording along with them. And if you search among posters for keywords such as transportation, mobility, aircraft, or automotive, you will find many related topics out there. And if you enjoyed this session, it will be posted. It's been recorded, and it will be posted, so you can encourage your friends to have a look as well. Any final comment, or we will wrap up and close? I think we're good then. Thank you all for joining, and let's go visit the other sessions now. Bye, everyone.
Bye-bye.
Bye-bye.
Bye-bye. Thank you.